Today we're going to be learning about linear inequalities. A couple of things just as a quick review for you. When we're talking about our less than and our greater than symbols, a couple of things I want you to remember. The equal sign, the little line below the less than, actually means equal to, so less than or equal to. And then without the equal to sign, it's just less than. So the two things I want you to learn now are, if it does have an equal to sign, it's going to be a solid line. So both of these, less than or equal to or greater than or equal to, are both going to be solid lines. And then if it's a less than or greater than with no equal to, it's going to actually be a dotted line. Okay, so those are the two big things for you to know. And then we need to know if we're going to shade above or below. So the way we do that is less thans are shaded below, because everything less than that is the solution, and greater thans are shaded above. And you may find yourself looking back at this chart a couple of times until you get used to it. Okay, so let's actually just practice plugging in numbers and seeing if things are actually a solution. Now, what we did yesterday when we were doing substitution and plugging in numbers is I had you first, instead of going ahead and plugging in numbers, is to take out the variable and put parentheses. So instead of an x, I'm going to have a parentheses. But then I'm going to do the rest of my equation. And instead of a y, I'm going to do parentheses greater than 5. Because what we've been given is an x value and a y value. So now I'm going to plug in. So into my parenthesis, I'm going to put a 3 for x, and I'm going to put a 2 for y. If you do it in this order, if you get your parentheses first and then plug in, you won't screw up your negatives. Okay, so 3 plus 2 is 5, greater than 5. Is that true? No, it's not true. 5 is equal to 5, but it's not greater than 5. So 3 comma 2 is not a solution to this inequality. Okay, so let's try it again. Same process. We're replacing our x and our y. So instead of the x, I'm going to put parentheses, minus. Instead of the y, I'm going to put parentheses, greater than or equal to 2. Now for my x, I'm going to plug the 5 in here. For my y, I'm going to plug the 3 in there. So 5 there and 3 there. So I have 5 minus 3. 2 is greater than or equal to 2. Well, yes, this is true because it's equal to it. So yes, that one's true. And then one more time. And this time, again, make sure we take out our letters and put on our parentheses first. So we've got negative, and then taking out our x and putting in our parentheses. That's a critical step right there, making sure the negative still exists. Okay, minus 2, and then again, instead of the y, I'm going to put my parentheses, are greater than and equal to 5. Now I can plug in. For my x, I'm going to plug in a negative 2. If I hadn't done my parentheses, I probably would have screwed up that negative. For my y, I'm going to plug in negative 3. So I've got negative 1 times negative 2 is 2. Negative 2 times negative 3 is 6. So I got 2 plus 6 is greater than or equal to 5. And yes, that one's true. So now we're actually going to start graphing our inequalities. And this is just almost a review of graphing lines, except that we now have to make the decision about dotted or solid and above or below. So if we look at our very first one, we've got y is less than 4. So our m Do we have an x value? No. So our m is 0 and our b is 4. Because if we put in our equation, y equals mx plus b, that's just a reminder so you'll remember how to get your m and your b. And then all we're going to do, since we have a 0 slope, is we have to decide, is our line going to be dashed or solid? Well, we have a less than, so it's going to be a dashed line. So let's get in our line. So at the 4, I'm going to put in my dashed line. And then I have to decide, is less than shading above or below? Less than is below. So I'm going to actually shade all the way up there to the line below. And that's my answer. I could have also put this into the y equals of the calculator and changed, instead of an equals, into a less than, and the calculator would have graphed it for me as well. Okay, our second one is x is less than or equal to -1. Well, first thing we know is this is an x equals. That means it's a vertical line. Our vertical line is going to be at the -1. So all we have to do is decide, is this going to be a solid or a dotted line? Well, it's got a less than or equal to, so it's going to be a solid line. So I'm going to draw it right there. And then we have to decide if we're shading above or below. Well, this is a little tricky. It's a vertical line. So we're going to have to apply a little brain thought. We know that all of our x's have to be less than -1. So it has to be everything getting smaller. And that's our shading. Okay, let's do the last one. On this one, we're going to need to find our m and our b. So if we look, our m is the letter with x, is 3, and our b is 1. So that tells us how to begin graphing. Now we have to decide, are we going to be graphing a solid or a dashed line? So let's look. We have a less than sign, so it's going to be a dashed line. And then we're going to shade, because it's less than, we're going to be shading below. Okay, so let's start by going to our y-intercept at 1 and putting a dot. And then our slope is 3, so up 3, over 1, put a dot. Down 3, backwards 1, put a dot. Down 3, backwards 1, put a dot. And we just decided that this is a dotted line, so I'm going to kind of connect my dots with little dashes. That's my line. Now I have to decide, am I shading above or below? I decided I was going to be shading below. So go ahead and just put your pencil back on the y-intercept. Below is straight down, so go straight down from the y-intercept, and that'll show you that all of this is shading below the line. Easiest way to remember above and below is put your pencil on the y-intercept and either go straight up or straight down if you're going above or below. Okay, so at the bottom it's asking, can solutions be on the line? Well, on this first one, it's a dashed line. There's no equals to, so no. On the second one, can the solutions be on the line? Yes, that's the difference between dotted and solid. So yes, this is a solid line. Solutions can be anywhere on that solid purple line. And then our third one, again a dotted line, so no. Now we have to ask specific points if they're solutions. So the first point we have here is 0, 0, a solution. So if I go onto this graph, my 0, 0 is right here. It's part of the shaded area, so yes, it's a solution. Now here it's asking about -1, 0. That's right there on that line. We just decided if it's on the line, it's okay. So it's on the line, so yes. And then our last one says -1, 0. -1, 0 is right here. It's outside of our shaded area, so I can just look at it and go, nope, that's not a. Okay, so pause your video and go ahead and do 7, 8, and 9 on your own, and then just come back and make sure your sketches and shadings and solids and dashed are correct. Okay, just look at number 7 and make sure you got it correct. And then we're going to move on to 8 and 9. 8 and 9 we're going to do together. On 8 and 9, we can't really graph this until we have it into slope-intercept form. Or we could just use our calculator, because I could get this into the y equals form for the calculator like we did with systems and let the calculator graph it for me. Okay, so if I want to do that, I'm going to do what I was doing before. I'm going to say parentheses, the opposite of x, close my parentheses, and divide by the number in front of my y. Now, this is the critical step. Remember how when we were working with inequalities, I always had you do the negative checker? Got the same thing. We're working with an inequality, so even if we're just using the calculator form of y, if we divide by a negative number, we'll have to flip our inequality. So this time we did not, so it's going to be just like that. So if we put this into our calculator, we can then just pull up our graph and see where our line goes. Okay, so I put it in the calculator. I looked, I could see that I have a nice little positive line. I'm actually going to go to the table. I'm going to let my calculator give me some points to do my line. So when I press second and table on my calculator, I have a line at 0, 1, or a point at 0, 1. So there's a point there. I have a point at 2, 2. There's a point there. I have a point at 4, 3. So 4, 3, I have a point there. Okay, and I look at this and it looks like something's wrong, so I'm going to go back and look at my table. Ooh, no, my first point is 0, 1. So it's actually right here. So we'll ignore that other one. So it looks like we're going up 1 over 2. Up 1 over 2. So let's go down 1 and backwards 2. Down 1 and backwards 2. And now I have the points to where my line goes. Next thing I have to do is decide, is this going to be a solid or a dashed line? So if I look at that, greater than sign, it's going to be a dashed line. And then I say that's a greater than sign, so I'm going to put my pencil on my y-intercept and I'm going to draw straight up. And that's going to be where I shade. Okay, so what we learned in systems will make graphing lines so much easier than they have been in the past, and it should help you keep from making any sign errors. Okay, let's do number 9. Okay, first thing we need to do is get it into the y equals format, so we're going to do calculator, or parenthesis, opposite of x, close parenthesis, and divide by, what are we dividing by? We're dividing by -1. Okay, remember what I just said? If we're dividing by a negative, we have to flip our inequality. So we're going to rewrite this. Y is greater than, parentheses, 2 minus x, close parentheses, divided by -1. Okay, so we've accounted for our negative division. All right, so let's go ahead and put this into our calculator. And just look at the graph. We see it's a positive graph. And then go to the table. So second table. Now let's go ahead and plot a few points. So we've got 0, -2. That's our y-intercept. We've got 1, -1. We've got 2, 0. So looks like we're going up one at a time. Okay, so I got my points. And now I need to decide, is this a solid or a dotted line? And I look right here. It's going to be a dotted line. And that says greater than. So I'm going to put my pencil on the y-intercept. I'm going to go above. I'm going to go up. And everything above my dotted line is going to be shaded. Okay, so this next one gives us a graph and asks us to write the inequality that represents it. You can go about this a couple of ways. way I would recommend doing it is, well, there's two ways. First way you could do it is to say, okay, my y-intercept is right here at the -1, and then my slope. So I need to figure out my rise over run. So if I get a second point right here, looks like I'm rising 2, going up 2, and going over 1. So my slope is 2 over 1. That's going downhill, so it's negative. So I now know my m and my b. So I can write my inequality using my m and my b. Now I need to decide, is this line being shaded above, or is it being shaded above or below my line? Well, if I put my pencil back on my y-intercept, my shading is actually going down, so it's below. And my line is a solid line. So that tells me exactly what to use for my inequality. So I've got y, okay, shaded below, so less than, solid, less than or equal to, and then I've got -2x minus 1. So it's using pretty much everything we already know, but adding on if it's a solid or dotted line and which way are you shading. Okay, if you have any other questions, then come to tutoring and help get it cleared up.